Hello, everyone, and welcome to the 1:30 p.m. to 2 o'clock p.m. session of the 2022 OpenSimulator Community Conference. In this session, we are pleased to introduce the presentation, The Basil Viewer Experiment. Our speaker is Misterblue, aka Robert Adams. Robert has been a computer developer and researcher for 40 years. Please check out the website found at conference.opensimulator.org for speaker bios, details of sessions, and the full schedule of events. The session is being live streamed and recorded, so if you have questions or comments during the session, you may send tweets to @OpenSimCC with the hashtag OSCC22. Welcome, everyone. Let's begin the session.
Hello all, I'm Robert Adams, aka Mr. Blue Waves. I've been working on OpenSim for forever, and virtual worlds for a long time. I mean, someone mentioned croquet, and I remember going to meetings with Alan Kay in the 90s, talking about the beginning of virtual worlds. So what this talk is about is I started building a viewer for OpenSimulator. And it's kind of an experiment because I'm trying out a new architecture. And so really this presentation is starting out by saying that I failed this year because the presentation title was supposed to be an OpenSimulator viewer on the browser and Unreal Engine. That is, I'd hoped last year to have built two browsers for OpenSimulator. One, it's a browser-based, and one that was Unreal Engine. How was I going to do that? Well, first, as kind of an aside, I believe that OpenSimulator needs its own viewer because it's held back by the capabilities that we have in the third-party viewers that everyone uses. People have been talking in the last presentation about different avatar types, different media types, different interconnection chat systems with different worlds. And we can't easily add those to OpenSim and experiment with them because of the limitations of the viewer. So there are several interesting single developer projects in progress around. I think tomorrow there's a presentation on redoing the viewer. But the Basil experiment that I tried out is an attempt to create a portable universal 3D world viewer. That is, a viewer that would work with any 3D world. So I wanted to be able to allow a VR chat avatar to stand next to an OpenSimulator avatar. And the way I was going to do that was the OpenSimulator is a virtual world simulator system, and it talks to the viewer. And at the moment, the viewer is very tightly tied with lots of world logic. That is, an OpenSimulator viewer is just not going to work with VR chat just because there's just too many differences in the world. So my idea was to separate world logic from the actual renderer. So the renderer could be any different engine, like a browser engine or Unreal Engine, or could be optimized for headsets or whatever it was, and that would be separated from the world logic. And so the world logic part is the user interface, camera object interactions, high-speed interactions that are inside the world, like one of the features of the Second Life viewer is that if an avatar is standing on slanted ground, the feet slant to match the ground, so you don't look like you have fat feet out. It's just little teeny world logic things that exist in there. And then you have this new renderer protocol that talks to the renderer itself. And this is just a little higher level than graphics rendering. It's not like talking bits on the screen. It's talking about things in a 3D space. So once that was done, it would be easy to separate or build two different viewers that just talked this renderer protocol and did this glue between objects in the 3D space and the actual engine. So it was going to be one viewer to rule them all. So you could have the OpenSimulator virtual world talking through this space server. That's what a term I took from the Siricata project that was done back at Stanford many years ago. That would provide that, it serves up the space that OpenSimulator has. And then Second Life would have a space server that would talk to Second Life. And then there could be a VR chat one, just as an example. And so on the other side would be the protocols for each of the different languages. And then the Basil protocol would be talking to the Basil viewer. So the Basil viewer itself was supposed to have world logic not embedded in the viewer. The viewer only provides 3D object viewing. And the protocol to the viewer is tuned for displaying these 3D objects. So it's a higher level than the graphics interface, but not all the way into like world logic. And then you could build different viewers for all the different views. So you could have a headset viewer, you could have a thing on the wall viewer, whatever viewer you wanted that would display the 3D items in the world. So what does a universal viewer need? Well, it's like I said, it's kind of just a little above the graphics viewer. So it should display 3D objects within a coordinate system. So that's this view that we have here into this presentation space. There's 3D objects in the space. It needs graphics acceleration. That is the interface to all the interesting things that the graphics cards do. Is now mostly done in shaders. You need boned 3D objects and animations for them. You need low latency local programming. Now, one of the reasons people mash the renderer and the 3D world logic together is for latency. And so what I was going to do was you had essentially scripts that ran in the simulator, which is like LSL scripts, and then you had scripts that ran in the renderer area, and those scripts would use a common system. I was going to use the WebAssembly routines. So things like, well, whether the feet tipped for the ground or wrist screens that you would have in your headset virtual world, those could be all done and uploaded to the renderers. And then you just need a WSM executor to work in Unreal Engine and the browser and that sort of thing. And then I also wanted flexible programmable UI. So I decided to use an existing system, HTML and browsers, on everything. So the user interface is all HTML. So what exists today is a very preliminary version of Basil. There's a OS grid region called Basil Alpha, which you can go to it in OpenSim. But if you go to basil.bluestuff.org, you end up with this web page here where you log into your OS grid account, and when you say login, it does the XML RPC request to the region to log you in. And then it reloads this page with the Basil viewer. And what it is the Basil Alpha OS Grid region has two main modules in it. One of them is what's called or is named the Loadin module. That is, it's a level that provides level of detailing of the region. So it converts the region assets to GLTF, which is a common graphics format that loadable by most graphics engines, and it's 2 years ago, I released the Convor app, which was an application that takes an OR file and turns it into a GLTF thing. And so that's all that logic is there in Loden. Currently, Loden is limited in that it generates one GLTF file, but someday it'll build all the dynamic ones, or build them dynamically and also in pieces. Then the Ragu module prevents all the space servers for OpenSim region. So the idea was you can have a space server for a different world, but why not have multiple space servers for your own world? And so the architecture allows each space server to have a different protocol, a different transport system, and so there's a space server for the static content of the region. There's a space server for the dynamic content. That'd be the animated or the scripted things. There's a space server for the actors in the region. And then there's a space server for the environment. So like when you go to basil.bluestuff.org and log in, at the moment, all the avatars are just ducks. It's a GLTF duck. And because I don't have avatars implemented yet. And you can move around the region using the arrow keys. Your browser has connected up to all of the space servers. They provide all the different parts. Like the environment one, this transparent, semi-transparent screened dialog that's in the lower right-hand corner, that's actually HTML. It's an iframe that's running on that page, and it loaded the HTML into that iframe, and it shows up on the page, and it's draggable and resizable. There's also an HTML title bar at the top. And the environment will also worry about the sun and that sort of stuff eventually. But you can have multiple space servers for multiple actors, and like the actors could be using a different protocol to do the quick updates for actors versus the static server, which just is to sign HTML. So that's how it presents the scene. And the individual objects in the world are objects, 3D objects with abilities. So they're items and abilities, which models the entity component module that is general in lots of 3D systems. And I would like to go more towards Pixar's universal scene description, since that's a standard that a lot of people are playing with. So I can tune it that way. And so like the avatar has a bunch of abilities, placement, like a position in the world. He has an assembly, which is the 3D object. He has an OpenSim avatar movement ability, which does the keyboard watching and that sort of stuff to move the avatar the way an OpenSim avatar. He has an OpenSim camera, so that the camera follows him. It also has the alt click and orbit view for an OpenSim, and it'll have OS Animate, which deals with walking and the animations of the avatars. So the ones with the OS would be OpenSim specific abilities that get added to the object. Quickly, as I built a browser-based one, there are several things in the way of building a browser viewer. The Linden Lab legacy protocol, which I call the existing protocol, uses UDP, which is not available. So you have to do something new in order to get to a browser. So you have HTTP, there's WebSocket, which is the one I'm using, which is kind of a funny wrapper around TCP/IP. And there's WebRTC data channel, which is, again, a TCP wrapper that's specialized for streaming data, but it also has a data channel. Browsers require security. That is, once you do an HTTPS request, everything from that page now has to be secure to prevent people going off and fetching stuff from strange places. And so all connections need certificates. And a lot of the OpenSim grids and regions are not generally SSL enabled. So I had to build reverse proxies to even just log in and use OSGrid, for instance. In general, OpenSim assets are unoptimized and in a proprietary format. And, the way the OpenSim, the third-party viewers work is they download all the data and they optimize it in the viewer. That needs to be fixed because the browser doesn't have enough resources to do that, and that's what load-in is supposed to be doing. So there's a lot of pre-optimization that has to be done with mesh simplification, building texture atlases, doing level of detail stuff, and that's a lot of work. And the browser code is single-threaded, so multi-threading is possible, but it's difficult, and that limits what a browser can do. Like I said, this is in progress in ALSA version. What needs to be done yet is a region level of detail assets. The avatars need to be implemented. There's lots more user interface like chat. I tried to get chatting working this week, but there's more to go. Get the WSM ability implementation, asset manipulation security. That is, if you're going to have this local scripting, you also have to have access control. Of course, the Unreal Engine version. And also, when I drew the original picture, the space server was a different program that sat in front of the simulator. The current implementation is all region modules, and that was kind of because I didn't want to build another program because it's essentially a super copy bot. I didn't want to deal with that problem, but that's one needs done. And I think there's a lot of interest. There can be some interest in this, but one of the things that I've found is that there is so much work to be done here. It's a gigantic job. The reason people have talked about new viewers for over a decade, and they always say, well, it's essentially 3 man-centuries of work that need to be done to build a new viewer. And it is. And there's lots of areas expertise. It was all written in C#. Maybe a team could really brag it, but it's got graphics, it's got mesh manipulation. You have to be a CSS wizard for the dialogues. There's C#, there's TypeScript, there's security. It just goes all downhill. And it's also not really an OpenSim viewer. Like I said, Basil wants to be the front end for lots of different viewers, and we'd have to have the discussion of how Second Life compatible OpenSimulator should be in the future. It could take a different branch. Chat could be different, objects could be different, the content creation pipeline would be different, and it diverges from OpenSimulator in both protocol and features, which is exciting and also different from the way it's all been done. So if one's going to build something new, it'd fit with other virtual world projects. We need Ready Player Me avatars, the VRM formats going around, new content workflows, everything else. It's a new world. To wrap up the talking part, there's a test region on OSGrid. You go to basil.bluestuff.org and you can give it a try. And all the sources are all open source. They're all in GitHub. I had started this Herbal 3D project. This talks just about Basil, but this is part of a general idea I had of taking over the world of virtual reality and augmented reality and building tools for all of those all at once. But this is just one small part of it. You can contact me, email me. I'm in Worlds, I'm Discord, I'm around. So if you'd like to talk, feel free to talk to me.
And what booth are you in? You're on Expo 3?
I'm on Expo 3, right behind the Core 1. I think it's booth number 20.
Okay, there you are. And we are just out of time.
Yeah. And so let's see, there was one question about Unreal's licensing. Yes, it has licensing problems, but there's no reason to use it. You can use Godot or any of the other viewers in the world if you don't like the licensing. The question was, Unreal has a reasonable license for small things, non-commercial things, and we like non-commercial things.
Okay, and there's other questions, and I'll pass those on to you.
Okay,
Robert. Thank you very much. Thank you, Mr. Blue, for an informative and interesting presentation. As a reminder to our audience, you will want to check out conference.opensimulator.org to see what is coming up on the conference schedule. You won't want to miss our next session, which will begin at 2:00 p.m. in this keynote region and is entitled VWEC Brings Educators Together Across the Metaverse. Also, we encourage you to visit the OSCC22 Poster Expo in the OSCC Expo 3 region to find accompanying information on presentations and explore the hypergrid resources in OSCC Expo 2 region, along with sponsor and crowdfunder booths located throughout all of the OSCC Expo regions. Thank you again to our speaker and the audience.